Guys, let's finish out chapter 1 and then head out. Let's do that. Section 1.8. It's going to be our first little step into some algebraic ideas. And when people always tell me, when you first see algebra and you talk about why the hell did they have to get all these letters involved and all these number stuff, what the hell? But what algebra does for us, I desperately want you to understand this, it lets us work with something I don't even know what the hell it is. So if I just said, I don't know something, I don't know how much Bob makes, and then I want to double it, I can't write that anyway. It's like Bob makes something. What do I put there? So really, I want you to realize it. And let me write this down. I make twice as much as Bob does. Right? Poor little Bob. You with me? I make twice as much as Bob does. Right? You can talk to Bob. He can tell you the same thing. How much does Bob make? We have no idea how much. I wish he made $1 million, because then I make $2 million. Look at that. I love it. So I don't know how much Bob makes. So all algebra does is it settles on a symbol to use for the unknown. And in fact, as you move through your math courses, you'll realize you don't always have to use X. You can use T if it's time. You can use C if it's cost. You can use letters that mean something. But for us right now, the most general thing we're going to use is X. So now why does Bob make X? Because I don't have a clue how much Bob makes. So algebra says, okay, just call it X then, because we don't know what the hell it is. But the reason that's so useful, it's like, yay, Jeff, you still don't know what the hell it is. You just call it X. Way to go, math boy. So, but if I make twice as much, how much do I make? Twice X. Kind of with me? Now, if I said, together, Bob and I make $300 in a day or whatever. Are you kind of with me still? Yeah. If together, Bob and I both make $300. Together. So that would be me and Bob, and Bob's what?
X.
We make 300. That's going to be when we get to solving equations. Equations represent situations involving unknown amounts. And when does that happen? Every freaking day. Every freaking day we have stuff we don't know. Right? So we have to kind of make decisions. Well, if the economy gets better, will it? I don't know. If it does, we'll do this. And then you have to do calculations. So what the hell are you going to put in there? You're going to put unknown stuff. And you can say, well, if the economy gets twice better, I can put a 2 in there. If the economy gets 30% better, I can put something in there. I mean, you guys kind of follow me a little bit. So this helps me write a general situation. And then, for example, when we get to equations, I can actually solve for the amount. Or if I don't tell you the 300, if Bob makes 500, how much do I make? 1,000. Twice 500, 1,000. So all I have to do is tell you one value, and you know both. Do you kind of follow what I'm saying? It helps me identify my unknown, build other things I don't know, and the minute somebody tells me that one thing I don't know, it's like dominoes. I know all this other shit, right? Or if somebody tells me something, please let me know something. If I know something, I can maybe work out what that unknown quantity is. So that's really the beauty of algebra. It says, I know you don't know it. Just call it X. And some people are like, ooh, that's great. Let me call it Fred. What the hell? But that helps me write expressions that involve that unknown amount. It's better than 2 blank space. I can't do shit with that. I need something I can actually see and do stuff with. Okay, cool. So that's really the function, that the reason variables exist, is to take the place of something I don't know yet. Nobody's told me what that is yet. So, if I have the most fundamental thing in algebra is the ability to plug in numbers for variables, right? And that's really what section 1.8 involves a lot of. So for example, if I had this problem here. Now, you cannot do anything with that. So if you're sitting there like, I can't do anything with that. Good. You're right. Don't freak out. I don't know what 4x minus freaking y is. Like, what, pineapple? I don't know what the hell it is. But if somebody told me x is 3 and y is 7, this is just like I said earlier. This is some expression that represents some unknown quantities. If I find out what they are, I can plug them in. You kind of with me? Yeah. So, for example, anybody ever heard you ever heard about the if you listen to a cricket chirping, the amount that it chirps directly relates to what the temperature is? Have you ever heard that? No. For my older people. So if you ever hear cricket chirping, how quickly it's chirping actually relates to what the temperature is. And you can actually set up the equation. So your equation would have an x where the chirpings go, like maybe the number of chirps per minute. Are you with me? So you got to be really bored to be like 1, 2, 3, 4. Tell me when a minute's over. Yeah. But your equation will have an x there, so that if you go somewhere you hear a cricket chirping, and you hear it, and it's like 40. You put a 40 in, and you get your answer. And you go somewhere else some other day, and it's like 100. Like, damn, it must be hot. So you do 100. But your equation doesn't change. It's still whatever x. What changes is the values you keep plugging in. Are you guys kind of with me? So that's the power of algebra, is to represent a general situation, and you put specific stuff in to figure out what to do then. So here is my general situation. There's my specific information. How the hell do I go from there? How do I rewrite this? What does this mean? Good. So 4 times x, but x is 3. Don't write this. Now, what would be wrong? If I wrote this, what's that? 43. It's 43. No, it's got to be either do that, or better in general, just always put it in parentheses.
So you do a dot or parentheses?
Yeah. Parentheses in general is actually better because it helps maintain the operations better. I'll show you what I mean here in a minute. So I get 4 times 3 minus 7. I like it.
5.
Good. 4 times 3 is 12. I like it. Cool. Right? This
Can we do instead? Can we have like 4.3 as exponents? Let's say 4.3.
Not for this given equation, right? Not for this equation here. But you can have a different equation that has it up in the exponent, sure.
Okay.
So I could have an equation that looks like this. Let's really go crazy. Okay. And this is where I want you to let go of looking at a problem and say, oh, there's so much shit. Oh, God. The problem has little parts to it. Each little part is going to be relatively easy. It's not going to be bad. You don't have to do the whole damn thing at once. So what are the operations involved in here? Good. 2 to some power divided by the sum of 2 things. I don't know. There's 3 things I don't know. And that's a lot less than normal. Normally, there's a lot more that I don't know. But if I suddenly tell you, okay, x is 3, y is 12, and a is -4. So you just rewrite the form of the formula, right? And you just plug in the stuff that you know now. So how can I rewrite this? 2 to the 3rd power, right? Because x is 3. I'm just putting in place of x and putting 3. On the bottom, 12 So in general, to get you always could put it in parentheses because sometimes they're just not needed. And that's not a mistake. You just can take them back out. But sometimes you desperately need them. And so that's good to have them there. So you can always put parentheses around whatever you're plugging into a problem.
Is that an X you got above the 2 up there?
Yeah, that's an X. My X's get a little freaky. So that's an X, yeah. So it's 2 to the X, but now I know X is 3. You guys kind of still with me? So it's just replacing something I don't know, and then somebody came along and said, oh yeah, X is 3. So I can put a 3 wherever I see an X. So what do I get on the top here?
8.
Good. 2 cubed is 8. And what's 12 minus 4? 8. 1. Cool. That's uglier than you'll actually see in the book. But that wasn't that hard. It's replace the variables with what they tell you they are and then work the problems out. Right? That's the idea of that section of homework. Let me see if they give you any freaky things. Nothing exceptionally freaky. Oh, yeah. So I think let me show you one last thing and then we'll head out. Now let me really point this out. There's some of you guys are in this class not because you don't know some of the early stuff, because you had trouble with some of the later stuff maybe. So some of you guys know how to solve this equation. Cool. Does this say solve the equation? No. So do not solve the equation or else it's wrong. So be really careful. Right? I know it's nice you know how to solve an equation. We're not asking you to do that yet. This is a required skill also. This is checking a solution to an equation. You have to know how to do that. So really, how do I check to see if 3 is a solution to this? It means when I plug a 3 in, does it make it work? That's what that means. So when you plug a 3 in, what do you get? You get 4 times 3 minus 1 equals 10. What's 4 times 3? 12 minus 1. You get 11 equals 10? No. So is 3 a solution? No. Is there a solution to this equation?
Yes.
Hell yes. It's just a fractional or a decimal answer, but it's just not 3. That's all I know right now. So when you see that in the book, that's exactly what you do. You plug it in, and you see if it's true. If it's true, yes, it's a solution. It makes it work. If it's not true, no, it's not a solution.
That's one of those on the homework?
Oh, yeah. Good?
No.
What's up?
All right, you made it 4 times 3.
Yep.
How'd you know it was times 3?
Because is there a plus sign here?
That's not an X, like, no, there's no plus sign.
Is there a minus sign?
No.
Is there division?
No.
What's the only thing left?
Yes,
All right, but even better, I don't want you to do process of elimination every damn time. If there are 2 things sitting next to each other, a number and a letter, that means multiply.
All right.
Sweet.
That'd be 11 minus 1 is 10, right?
Well, 12 minus 1 is 11. 12 minus 1 is 11, so it doesn't work. All right.
So if you would have used an 11 instead of the 10.
If I would have put 11 there, it would have been the solution. Exactly. All right. That's plenty. I'll see you guys Thursday. We'll probably have a first quiz next week.
Next week, Tuesday?
I'll tell you on Thursday. No.
When do we get our work back?
I gave. Oh shit! I didn't give some. Shoot.
So what's the whole
Tracy, are you still out there? Tracy. Kyle. Kyle, are you still here? Where's Tracy? I get that earlier. I forgot all about it. So I get them graded the next time after. So you'll get this back on Thursday.
homework on 1.8 homework?
Yes, definitely starting to 1A.
I don't. I thought. I thought I give you 1.8.
Oh, good.
Yeah.
Yeah.
No working.
Yeah, you can, yeah, you're good. You can get a little ahead if you want to in chapter 2.
Yeah, I like it a lot.
Good.
Okay, thank you.
Sure. See you.